record. It's recording. And yeah, so let's go ahead and get started. Um, so let's start with some announcements. Um, this is an Upsilon Pi Epsilon workshop, part of the program UPE code, for which I am the director. My name is Dewan Harris. Yes, the recording will be on YouTube after the workshop. So here are some of our upcoming workshops after this one. We're going to have Build Your First API with Node. That's Friday, October 16th at 6 o'clock. It's going to be a very interesting workshop. We just finished developing it, so you guys are going to like that a lot. Following that, on Friday, November 6th at 6, we're going to be doing a mobile development with React Native. If you are not a member of UPE, I would encourage you to go ahead and join. You do not have to be a member to attend all of the workshops, but you do get some great benefits out of being a member. So to join, go to http://upefiu.io. That's http://upefiu.io. Join our Discord. We have over 3,000 members in the Discord. So it's fun. You can go in there, talk with anybody about anything, and you'll have someone who shares the same viewpoints or likes the same things that you do. So that's http://discord.gg/UPEFIU. Our social media, UPE is on Facebook, Instagram, Twitter, LinkedIn. Follow us on all of those platforms at UPEFIU, and also follow the School of Computer Science and Computer Science. That's at FIU SCIS. All right, so now we're going to go ahead and get started with the workshop, Web Development Workshop Part 2. I am not going to be doing this workshop. It's going to be one of my committee members, Zachary Santana. So I'm going to stop screen sharing so he can start, and he'll go ahead and get started. So let me stop sharing. All right.
Hi guys, I'm going to be doing a JavaScript workshop, like he said. So let's get right into it. What is JavaScript? JavaScript was created by Netscape, which is a company, and they originally named it Maca. Then it was renamed to LiveScript after a while, and then Netscape and Sun changed it, made a deal, and they changed it to JavaScript. If you don't know, Sun is the company that made Java. So they wanted it JavaScript for the implicit advertisements of Java. So everybody always jokes around Java, JavaScript, but they're not really similar. Really quick, I'm going to pull up the chat next to Zoom so I can read it while I present. So JavaScript has 7 primitive types. The first one's a number. It ranges from 1, 2, 3. The examples are pretty basic. Nan is a number that really doesn't have a value. It's just there. You can't really do operations with it very efficiently. The next variable is string. It's signified by 2 quotation marks. And then you have some text in the middle. It's like an array of chars or a list of letters. You can also use a single quote. When you use a single quote, you can reference variables that's inside of your code. When you use the double quote, you cannot. So this is useful if you want to embed some variable in it. So variable here might be like someone's name, and it would say Zachary is cool or anyone's name is cool. Boolean always has 2 types of data type. Are you going to share this presentation slide after the workshop? I'm sure. I'd have to pass that on to my, yes, we will be sharing. So Boolean has 2 types, true or false. Some people might refer to it as 0 as 1, but that's kind of a little weird. You can just call it true and false. Null is explicitly set for variables with no value. So some object or some variable might have no value, and then we'll just call it null instead of something. Undefined are for variables that have not been defined. So it's pretty self-explanatory. So if I initialize a variable, but I don't give it some definition, it's undefined. But if I set it to null, it points to the type null. Symbols are JavaScript's version of objects or usage with objects. So unlike the others, it's more like all these are private, mostly dealt with primitives, but symbols is the one that connects it with objects. And then big int are for integers or numbers specifically, not integers, that are larger than this really gigantic number. It's extremely large. So types and operators, they're the 7 primitive types that we just went over. Operators allow us to perform operations on different values. So we have greater than, less than. Let me switch to Visual Studio Code. And I'll open a JavaScript Google Chrome so we can run the JavaScript in some HTML file. So we're going to start by opening a new folder, and I'll just create a new one here. I'll name it Web Development 2. And I'll open that in my Visual Studio Code. And once it's done loading, I think I can start working, yeah. So in this, I'll make a new folder, and we'll go over types and operators. And I'll just start by making a new JavaScript file. So this one, I can name it anything. I'll just name it types for now. So like I was saying in the presentation, we have like less than, greater than, less than or equal to. But first, so that we can see the output of our code, we want to make a HTML file and connect it to this. So let me do that real quick. Let me open here. Oh, no. Okay, so first we want to make a new HTML file. And by default, we're usually supposed to use index because that's what servers pick up as a default for the like web page. And so I did not prepare an HTML file beforehand, so we're going to have to start it with the doc type. In Web Development 1, we explained what that really does and like each part of the HTML file, so I won't be going over that in this one. So I'll be including my script tags in the header. Beginning. Okay. Usually, if you wanted to embed JavaScript right into the web page, you could either import it using something I'll do right now, or you could input the JavaScript right into the script tag. But since I'm using an external file, I'm going to reference it with source, and it's in the same folder, types and operators. So I'll just put types.js. So this tells it that the JavaScript in types, we want it to be embedded into our HTML. So I'm just going to reveal this in my file explorer and open it. So it's going to open right here. And right now it's blank because our index.html is blank and our types isn't doing anything. But for the purpose of this tutorial or workshop, we're going to be using the console right here in JavaScript or any web browser. I accessed it by clicking right-click and clicking inspect and then going to the console tab. So when we log something in our console, console.log test, and we refresh this page, it'll log it in our console in Google Chrome. Do I have everybody? Have I lost anybody? Let me make sure I have the Zoom window open. Have I lost anybody? Does anybody have any questions? Or are we good? All right, so then I'll continue. Yeah. This folder is different from the last workshop for now. At the end, I'll reference the last workshop and we'll actually add some functionality to our portfolio. But for now, we're just learning JavaScript as a language. But at the end, do you always write the script tag in HTML? Does it have to be in the header tag? You could actually, I believe you can incorporate it anywhere, but when you compile it, it's going to get sent to the header. Like the server will force it into the header. So it's just standard notation to put it in the header. You could also put it in the footer. And I'm gonna input a dummy script just to show the difference. So that's gonna be types 2. And if I look at the source code and element, and I refresh the page, in the header, we have types 2, and in the footer, we have types. So you could input it either one. It'll run the header first, and then it will run the footer for any type of manipulation of the web page you do. But for our purposes, it doesn't really matter which order we want it in. So we're just going to input it into the header. But you can also input it into the footer. Does anybody else have any other questions, or we're good? This gave me an error because types2 isn't a valid JavaScript file, but that's only because I was doing the example. For now, we'll just keep it as types, as that's what we have in our folder. So is everybody good now? I can move on to what we were doing in the presentation, which is the operators for the types. Okay, so if we were to console log true, it'll just print out true because that's our Boolean value. And if we do it for false, it'll do it for false. If we did 3 greater than 5, or 6 is greater than or equal to 6, both of these, this one is false, this expression is false. So it'll return false and print out false. This one is true because 6 is equal to 6, so it'll return true and print out true. So if I save this and I run it, the first one's false like we said, and the second one's true. So there's also the operators not equal to. So 2 is not equal to 1. And there's also 2 equal sign variation. These are equality operators. They both do something different. So if we run this, both of them read true. This one, wow, I'm having a brain fart. So what it's saying, I'm getting a little nervous. I'm sorry about that. Raise your eyebrow at me, I see. Okay, so this one is saying not reference, but it's saying that they're, thank you. It's not saying the reference are equal, it's saying just the value of the variable. This one is saying the reference as well. So usually JavaScript will give you a small squiggly line in some editors that instead of this one, you would like to be using this one. But for our intents and purposes, they're the same. Thank you. There's also the operators for not and then some value. So if we did not false, it'll return true and it prints out true. If we did not and then 3 equals 3, 3 equals 3 is true and then it says not, so that'll be false. And we can also have some other logical operators like 3 equals 3 and, I did bad parentheses there, and 4 equals 8. Since 4 equals 8 is false, and it wants both of them to be true with the AND operator, this will return false. And we can also separate this with an OR, which is followed by 2 straight up lines. Most keyboards have that shift and then above the enter space or around it. And since this is OR, one of them is true and one of them is false. So it'll return true. And that covers all the operators in JavaScript. They're not that complicated. They're similar to a lot of other languages. But Now we'll move on to types. Or we did types and we did operators. So I guess we'll move on to the next slide, which is the program structure. Oops, I skipped this one. So the first thing I'll cover is conditionals. So if we had some number and it's equal to 10, and we said if that number is greater than 1, then we want to print something. 10 is greater than 1. And we ran our, or we refreshed our web page. It says true because 10 is greater than 1. I meant to put a string there. 10 is greater than 1. So it says that 10 is greater than 1. And we printed 10 is greater than 1. If we wanted to combine what we learned in the first slide, which is the single quotations, and we put in a variable, you could say variable number is greater than 1. Oh, did I do something wrong? Yes, I forgot the curly brackets. You have to put curly brackets with the $sign so you can reference the variable. Wow. What did I do wrong? That actually backticks. Oh, I thought I replaced it with backticks when I deleted it. Yeah, I was over skipping that. I thought I replaced it. Oh, my IDE forces it to, that's no fun. Right when I save the file, it switches the, it switches it. Yeah, I did not notice my ID. It's never done that before. I guess it's because it's a new workspace and I opened a new folder. That's inconvenient for showing this example. That's very inconvenient, but I guess I'll skip that just for now. Usually, if you have the single tick quotations and you have that exact notation, which is like this, it'll print whatever the value of that variable is. So it would print 10. Because my IDE is, or my text editor is forcing it to be double quotation, it's not doing it. That's really weird. It's really weird, but if your IDE does that, I'll just look into it. It's probably an extension that's overriding it. I probably have some formatting extension that's doing it. So we'll just move on. So you can also incorporate like an else statement, just like any other programming language. And we can log something saying that the number, just imagine those are single quotes, is less than or equal to 1. And if we changed our number variable to be -10, and we refreshed our page, it says that the number is less than or equal to 1. We can also have nesting conditional statements. And I also wanted to point out that I've been putting semicolons on each line, at each line of code, but JavaScript actually doesn't care. Well, my IDE cares, but JavaScript doesn't actually care about semicolons in that, so I could leave out these semicolons like so, and it would run in the browser just as well. But my IDE cares about it, so it adds it, unfortunately. I'm not sure why my text editor is formatting such strict rules, but we can also add nested conditionals. So after we do that if, we could say let, I'm not sure, insurance age, let's say we were like an insurance agency, and the person's 19, and I'm trying to get car insurance, and we have to be insurance minimum is, let's say, 25, because usually young people aren't safe drivers. And let's say our insurance age is greater than insurance minimum. That means that we're old enough for the minimum price. And we can say whatever code would do the minimum price, but we'll just log something out. Minimum price applied. And we can say else, which will say the insurance age is less than, and say you're too young for minimum price. And if we run this, it'll still say less than because our -10 is less than 1. So if we switch this back to +10, it should say issue young for the minimum price, and then the number is greater than 1. So besides else and if, there's one more conditional statement that's a combination of the two. We have else if, and then some condition. So for this condition, I'll say let insurance maximum. Yes, I'll explain that in one more second. Let insurance maximum is 80, and I say insurance age is less than or equal to maximum. Or I'll rewrite it to greater than or equal to. I'll cut this. If the insurance age is greater than or equal to maximum, so they're too old for their car insurance, I guess, you're too old. And the final one is you're too young. So the reason I don't do single quotes is because when I do single quotes, my IDE forces it to double quotations. So when I try doing that, when I save the file, it auto formats it. I could go into the settings right now. Auto save. Save on save. Format on save. And change that so it doesn't format it when I save it. I'm not seeing the option right now, so we'll just pretend that's single quotations if we want to access a variable in our string. So those are all three of the basic logical operators, and now one that's not widely used was a switch statement. So let's say our weather is rainy, and we get this by some method or some user input. We can add a switch statement, which takes in one conditional, which is we've just put in the variable. That should be weather. We just put in the variable, and then we test cases of what it could be. So rainy, and we do a log saying it's rainy, bring an umbrella, and we break off the switch statement. I think you're using quotes, and that formats to the backticks. I'll try that right now. Let's say our case is sunny. Then we'll log bring some sunglasses. I'll try this. It is, and then we'll input weather embedded into our string. Make sure to bring sunglasses. So look at that. I guess I'm a fool. Thank you. Thank you. Let's say it's cloudy. It's very protected. Don't worry, because it's cloudy. They don't need sun screen or anything. And let's say the default case, which is if none of the cases actually fire, then this default one will be called. If we don't include a break, let's say we didn't include a break here, it would run sunny and cloudy when the condition is sunny, which I'll show an example in a second. But the weather is unknown. So if you run this, it's rainy, so it's going to call the first one, and it's going to log it is rainy, bring an umbrella. If we change this to sunny and remove this line, it's going to run both of them because there's no break statement. This might be useful if you have a case that relies on the other case being executed when it's called. But let's say cloudy is called, it's only going to call cloudy. So I would say that's the one major benefit of a switch statement. Like I have some condition. What's the benefit of using switch? It's the one I was just trying to explain, that if you don't put break, it'll run both of these. So if I wanted it so like there's sunny, cloudy or something, and I added the case sunny, cloudy, and I put console.log, it's very cloudy, but also, and I put an appropriate message for sunny, and I added back the break statement for sunny, and I ran it, it'll run both of them. It's very cloudy, but also it is sunny and cloudy. Well, the embedded variable kind of ruins it, but that's the use case of it, that you want something after it to be called, and you can even chain it over and over. So if you had some amount of things that were just slightly different for the ones on the top than the ones at the bottom, then you could chain them, and then that's pretty much the only benefit of an if else. Some people like ifs and ifs else better, just because how they're formatted. Some people don't like switches, but I think they can be really useful if you use them right. So we went over conditional statements, and now I'll go over loops. You bring up this. So loops are probably one of the most important, and I wouldn't say complex, but they're the ones that get people stumped mostly in their code because of how the variables work. So it starts with some assignment, and then some condition, and then, ooh, I just want to write condition there, just as an example. Condition, or some conditional statement, and then it goes to some type of increment or statement to run. Usually it's followed by an increment, but you can change what this will do. This is just ran after every for loop. So this assignment will just assign the standard I equals 1. For the condition, we will have it less than 10 or equal to 10. And for the increment, we'll have plus plus I. I didn't go over this in the beginning, but plus plus I is the same as I plus equals 1, which is the same as I equals I plus 1. The same thing goes for I minus equals 1, and mine minus I, and I minus equals I minus 1. These are all the same thing, and these two and this one is the same thing. You can switch I minus minus I by I minus minus. This will return it after it adds, after minus it, and this will return and then minus it. You could also put I plus plus. A lot of people do I plus plus in for loops. It doesn't really matter because you don't use the return, but I'll just give a quick example. If we had I equals 0 here, and we logged I plus plus, it's going to return 0 and then add 1. So when we run it, it's 0. But if we do plus plus I, it's going to add 1 and then return I. So it's going to be 1. So it just depends on your use case, which one you use. In this example, in the for loop, we don't actually use the value. So it doesn't matter which one we use. We could even put I plus 1 or E plus equals 1, but that's just the shortest notation. So that's what people use. So do we have any questions? Have I lost anybody? I know I've explained a lot in a short amount of time. Are we all good? Does everybody have their text editor set up correctly? Okay, then I continue. So the use of a for loop is that we can use the variable I. It'll run 10 times, and we can use it to change each 10 times how it's ran specifically. So if we wanted to say the square of I, which will give us all the square numbers from 1 to 10, we could say this. The double star asterisk operator means to the power of. So if we did I star star 3, that's the power of 3. If we did I star equals 2, that just multiplies I by 2. If we did I/divide equals 2, that divides it by 2. If we did I modulus equals 2, it does the modulus operator, which gets the remainder from I as it divides it by 2. Can you zoom in a tiny bit? Yes. Is that better? If I zoom in again, I think it'll start cutting it off. Yeah. Okay. So this will print 1, 4, 9. Yeah. 1, 4, 9, 16. It'll print all the squares. Besides the for loop, we also have the while loop. The while loop just takes in a condition. So if you don't need to assign something and you don't need to increment it, then we could just have some type of condition. So let's say we had a game over condition, like we wanted to run some loop until the game is over. So initially the game is not over, it's still going. So we want not game over. So while the game is not over, it'll run this loop. And usually you would have some type of game code. But for now, we'll just say I equals 0. And we'll add I every single time this while loop runs. And then if I is equal to 10, then we'll say game over equals true. So after 10 iterations, the game ends. So if we log each iteration to keep track, count is at, and this time I'll use concatenation, which is when you add a string and an object. And I'll log when the game is over. The game has ended. I'll remove the earlier for loop. And if I refresh the browser, the count is at 1, 2, 3, 4, 5, 9, 10. The game has ended. Also, one side note, a good feature of Chrome is that it tells you the line number. So this says line 8. So at line 8, that's when I console logged it. While loops are usually used for some type of loop that doesn't have a specific end. This does, but in a game, you don't know when the game's going to end. So that's when you would use a while loop. You could also just have it loop infinitely. So if we wanted it to loop over and over until the end, we could have like while true. And we could have some conditions or something. But for now, we'll just have a variable on the outside and we'll increment it just like last time. And well, let's say when x is equal to 5, we want to break out of the loop. We want to stop it. Instead of using a game variable or anything, we can just call break, and break will stop it. And we can log the loop has broken. And instead of equaling, we can also do something like modulus, 20 equals 0. Modulus 20 will say when the remainder is no longer 0, then this is true. And if we run it, the loop is broken. But if we wanted to do a print statement with every increment, we say the increment is at, we'll do concatenation again. And the increment is at, I forgot a space, but it goes all the way to 20. We could also skip iterations. So if we wanted every even integer, we could do let I equals 0. I is less than 10 plus I. What's the difference between reference variable and just concatenating the variable itself? Well, it's just for simplicity's sake. So if I had some variable let x equals 5, and I had some variable let y equals 5, and I was like trying to plot it in a graph or something, like the point is and then saying X, saying in a little coordinate system, X, Y, and I change these to backticks. This is what it would use with that type of formatting, and it would say 5, 5. But if I use concatenation instead, add plus, X plus, it becomes quite lengthier than you would usually have it, plus Y plus. So both of these will print the same thing, but it might be harder to read this. Like I don't know if I mess up a space, it might be hard. Yeah, it's more idiomatic as well. But I think the main benefit is like it's really easy to mess up with so much quotations, especially if you have something that requires quotations. Like if you're inputting like quotes of something if someone said or anything, it's easier to mess up. And this is kind of just embeds it into the string and it's easier to read. So back to skipping every odd number and only having even numbers. So to get every even number skipped, we would do I modulus 2 equals 0. But if we want every odd number skipped, we could equal it to 1. So if the remainder is 1, then we want to break, or we want to continue. And if we log, or actually we'll break on every even number. That way we'll get every odd number. And we log, for example, we'll concatenate I plus is an odd number. We refresh our document. It did not print anything. So when I break out of the whole loop, and the first number is 0. So 0 modulus 2 is 0. So it just breaks out of the whole thing. So it doesn't actually run the rest of the code. So if I switch this to continue, it runs 1, 3, 5, 7, 9. Continue is different from break in that when it says continue, it doesn't mean continue the rest of the code. It means continue the next iteration of the loop. So instead of putting break, which stops it there, continue continues the next iteration. So if I equals 0, this will be true. It'll go to 1 instead of running this console.log statement. And the final loop I'll go over is the do while loop. Do while is exactly like while. And let's say we had some variable error and it equals true. And we put in the conditional for while error. And we logged that there was an error. It'll run it once, and there's not an error. It'll run it once. Oh, wow. It'll run it once, and then it'll check if there's not an error. Since error is true, and we have not true, it'll be false, so it'll only when it runs, rather than running it infinite. If we remove the exclamation part, then it'll just continue spamming, signified by the number next to it, that there is an error. So after that, we've covered loops and conditional statements, so we'll move on to object types. We have functions, arrays, and objects. But before that, I want to go over variables a little more. Let me just open that back up. So, oh, this is still running. Oh no, I meant to stop it. Since it's an infinite loop, it's just going to keep on running. So I'm going to close this tab and just open in a new one. I shouldn't have done that as an example, but let me open back the console. So I just wanted to go over like the basic types of using keywords to initialize variables. Var is the old school original keyword that people would use to instantiate a variable. So we had a student name equals Carlos. Var is scoped within the global realm, and let is scoped within just its immediate block. So if we said let student name or student name 2 or student name 2 works is Zach. Var and let are scoped differently, but since they're in the same context, it doesn't matter. So if we just scoped this one, so if 5 equals, I don't know, 5, so it will be true. And we put the var inside of the braces. Student name is still scoped on the outside. So if we said student name, if we said console.log student name, it prints out Carlos despite it still being in the if statement. So it's scoped in the global realm. But if we put this let statement in here and we tried printing student name 2, it says that the reference error is not found because let only does it in its immediate block here, but var lets it go anywhere globally. So if I did student name, it doesn't give me a reference error because it's initialized with var instead of let. One cool feature is that if we have some variable like student name and we have it set equal to Carlos, and we wanted it to now be set equal to 5 for some reason, JavaScript's dynamically typed, so we can just change student name to 5, and it'll just change it to 5. It doesn't matter that it was originally a string. In other programming languages that you have to specify the data type when you assign it and when you initialize it, you can't just set it equal to another data type. So if we log the student name here, and we logged it before we changed it, it'll print out Carlos and then 5, just like we wanted. There's also one more assignment operator that we can use, or not assignment operator, but instantiation operator, and that's constant. Let's say we define a constant pi, and we have it equal to 3.1415. And we would go on if we wanted an accurate representation of pi, and we logged pi, so it'll print our constant. And we tried changing pi. At first, it'll just print out pi, but if we tried changing pi to, I don't know, 3, because we're an engineer, and we run it, it'll say assignment to constant variable is invalid because we tried changing a constant variable. Constant variables can't be reassigned to any type of new variable. So does anybody have any questions before I go on? Is it smooth? Is everybody understanding it so far? Yeah, because we're an engineer. All right. So now I'll move on to object types. We have functions, arrays, and objects. Functions allow us to modularize our code. So it'll allow us to have a variable that when we run that variable, it does some code. Arrays allow so that we can have a list or a collection in some order of variables that we can access later. Arrays are usually paired with some usage of a for loop or some of the sort so that we can go through the whole array. Yeah, var declares in the global scope and let is local. Yeah. Objects are collection of relevant data. If you've used Java or some relevant programming, you have experience with object variables or object types. So first, I'll go over functions. First, we'll declare a function. So we could say a function get number 5. Oh, someone asked what's the difference between let and var. Let is the global scope. Let is the local scope, like he said. So we define some let here, and var is the global scope. So we've defined var here, we can use it out here. We define let here, we cannot use it out here, because let only exists between the two braces that it encapsulates it. So if we said get number 5 and we return 5, this function is now gonna call, and we're gonna get the value 5 when we call it. So if we just called it, we wouldn't see anything. But if we did a console log and we said the number 5 is, which is a little redundant, and we called get number 5, and we ran it, the number 5 is 5. If we also did something like we logged every time someone got the number 5, so someone is grabbing the number 5, and we refreshed our page, someone is grabbing the number 5 is 5. So besides the use of this very elementary use, we can also increase the functionality of functions by passing in a parameter. So let's say we said convert temperature, so we have something a little more useful. And we're going to convert it from Celsius to Fahrenheit. We can define our Fahrenheit as a ratio of, from Celsius, it's this formula. So we'll just do Celsius times 9/5 plus 32. And that's Celsius to Fahrenheit. What is that webpage? And we just returned Fahrenheit, or we did a console.log so we can see the immediate effects. And we said in Celsius, it is, and we put Celsius. And we said in backticks, in Fahrenheit, it is, and we referenced our variable Fahrenheit, which I'll do a multi-line code. I guess my ID doesn't like that either, but I'll close this up so we can see it fully. This will print out nothing because we never actually called the function. So we convert the temperature of 0 degrees Celsius, it should give us 32 Fahrenheit. So Celsius is not defined. I think I spelled it wrong. Yeah. Celsius. This one is spelled correctly. So now that I've actually spelled Celsius correctly, I hope I did not spell it correctly there, but now that I spelled Celsius correctly, it says in Celsius it's 0 and in Fahrenheit it's 32. We put 100 degrees. Then in Celsius it's 100 and Fahrenheit it's 212. And we search to Google Celsius to Fahrenheit and we put in 100. It's 212 just like Google says. So we did in fact actually convert Celsius to Fahrenheit. So if we ever needed to, we could use this function. Besides this, we can also create a default value for our parameter. So if we had say hello to, and we wanted to pass a name, and we included a default name, and we said it's Zach. If we said the name equals Zach, then let's log, hey Zach, how are you? But if it doesn't equal Zach, let's say equals nothing, because they put in nothing, then we can say console.log, you didn't put in a name. Let's say they did put in a name, we could finally actually log, and we'll embed the name variable. Hi, how you do? And if we run this, nothing will happen again because I forgot to actually call the function. So if we ran this and we put Eric's name in it, and we ran it and we put nothing in it, and we ran it and we put my name in it, it'll print out 3 different lines. It'll say, Eric, how are you? You didn't put any name, and Zach, how are you? So with this, we have like some functional programming that we can use. Like we can define a default variable for the function. You can actually, I introduced it earlier, but we can return something from the function that we can use. So if we wanted to, I don't know, function get squared, we passed a number, which is going to be default. Let's just have no default. And we wanted to square that number. Oh no. We wanted to square that number. We don't actually print anything, but we just return it for later use. So if we wanted to say, what's the square of 100, then it should reprint 1 million or 10,000. Yeah, 10,000 because it adds 2 more zeros squared. But if we wanted to functionally code something more useful, we could have, let's say, the cube, get cubic of some number, and we could return number times 3, which raises it to the 3rd power. And we could log the number, get cubic of 5, which should return 125. And we can also define functions in a different way. Instead of defining it the classical way with the word keyword function, we could define it with an arrow function. An arrow function has some variable. In other languages, you would put the data type. In JavaScript, you would just put the name of the variable you like to pass through the arrow function. You can choose whether or not to put it in parentheses. Some people will leave it as this, which is just as fine as putting it in parentheses. And inside we'll do the same thing as a regular function. Const is basically the equivalent of final in Java. Yes, it's exactly like that. And it'll give you an error when you try to reassign it. So for this function, we're going to do a factorial. So we're trying to get the factorial. Would it be local or global? That's actually a good question. Yeah, I'm pretty sure it's local, just defined within the scope of the wherever you define it. Variable just uses the global space of JavaScript runtime. So that's why people are moving away from variable or var rather than let. Because let and const only defined within this, so it can't mess up any other programming. So as I was saying with factorial, if we're going to input a number and we're going to get some number as the result, so we want to multiply this number result by every number preceding num and num. So we'll start at num and we'll work our way down to 1. So we want it to be equal, or we want it to be equal to or greater than 1, because we want to go all the way down to 1 and include 1. And we want to make sure that we provide the right assignment operator. So we'll subtract 1 from I every single iteration. And every single time this runs, we'll just multiply our results by that number. So it'll be like num minus 1, just like factorials are. as we multiply them out, and then we'll just return the result. So let's say we wanted to print the factorial of 20, which is a pretty big factorial. I don't know if there's enough. Let's do 10 instead. We get 3,628,800, which is the factorial of 10. Factorials get real large real fast, but the important thing is the arrow function allows us to define methods in a different way, and we can pass the factorial around just like a regular variable, and we can use it to call our method. So I discussed let and var, how their scopes are different. So we could also define a constant, and we'll call it hummus, and this will be an arrow function. Hummus has a constant inside of it. That'll be the ingredient. Ingredient will have an amount, a unit, a name, and this will also be an arrow function. And this arrow function ingredient will tell us how much of each ingredient that we want. In hummus, when we call it, we'll get all the ingredients, like run this function over and over for all the ingredients in hummus. So if we wanted to get the amount of the ingredient amount, we want to times it by the factor that we do it, which is defined in hummus. The factor in hummus is how much times, like how much hummus we want. And with this ingredient amount, we can just print it. And we'll use the single quotations. We'll say ingredient amount of unit. Unit, which would be like tablespoons or something. And then of name. If you wanted to, you could also define and change units so that if the ingredient amount is greater than 1, then we're going to add s to the unit, like such, which we could have done in the console.log, but we'll do outside just for cleaner code. And this adds an s, so if there's multiple amounts of the ingredient, there's going to be multiples as in the plural. So inside of hummus, we can say hummus has, for example, 1 can of chickpeas, and it has another ingredient. Me too. I'm hungry as well. It has a cup tahini. It has another ingredient, another cup of orange juice. It's my favorite type of juice. I don't know why we would put it in hummus, but let's say it has an ingredient of a clove of garlic. As it has the final ingredient of a tablespoon of olive oil. And let's say before we listed off the ingredients of hummus, we also logged the ingredients and we'll add the factor and 3. I'm not sure what the plurals of hummus would be, like 3 hummuses. I'm not sure. I'll just call it 3 hummuses with an apostrophe s, I guess. But we'll say the ingredients are these, and at the end we'll log a new line so that we know when we're doing our factors of hummus. and that's what we call the hummus function. And we'll call it with, I don't know, a factor of 1, humsy. That makes sense. I feel like that's right. And in 3, humsy. Yeah, I feel like that's right. I feel like that's right. So then we'll call like 5 in this one. So it's a factor of 5. And we run it. We get tablespoon is not defined. Instead of putting this in quotes, I put it in nothing. Oh, you don't know? Google says hummuses. Okay, I'll put that. Let's there hummuses. It's spelled hummus wrong too. There's 2 M's. Not that it's too important because it's just a name, but there it's fixed. So we got a reference error variable, reference error, because tablespoon I didn't put in quotations, so I just put it in quotations by double selecting it, put in quotations, and we say that the console log did 1 hummuses, which I guess I should do the same. I get the same logic that I did in ingredient amount, huh? So if we were to just add that same logic, we'll just define hummus or unit. I will call hummus as a unit, and we'll say originally it's just hummus, but if the factor is greater than 1, then we'll say unit plus equals hummuses, like that, and we'll just concatenate it at the end of this. So we'll say unit, and if we run this, the one that has a factor of 1 has just hummus. The one that has a factor of 2 should just have hummus, but I duplicated hummus there. Now it has hummuses, and this one has hummus, each with their respective factors of each ingredient. So now you know how to make a cookbook. It's pretty simple. All you need is a bunch of hummus, apparently. So let's say we also wanted to nest functions inside of functions, or functions inside of specifically arrow functions. We could say my name, and let's say my name is Carlos. Although it's not, but, and we wanted a bit late, but what's the dollar? Yeah, the dollar keyword, it's referencing a variable. So I'll just show you a little quick example. Let's say we had combined names, and we used the backtick to use it, and we did the dollar with the curly, and we can put in some variable, like my name is my name. And if we logged combined names, it'll say Carlos is my name, rather than just doing this. And it'll say this, which is not Carlos. So we want to pick the backticks. The benefit of using this is that we can have smoother code, and we won't have so much concatenation all around. So anyways, let's say we have my name is Carlos, and we define an arrow function, say my name, has no parameters, to just log the name. That is my name. And we reset my name to Zach, as it should be. And we called our arrow function. Since we redefined my name, it's going to say Zach instead of Carlos, because we redefined it. Despite this having my name here, it still references my name. So when we redefine it, it uses the redefined variable. But let's say we had this function adder, and it accepts a x variable, and we have it return a function, add y to x. Yeah, it's focused on functional programming. Its main purpose is just, like, its main usage is for web pages to just have some form of dynamic code to manipulate the web page. That's its main use. So most of it's just functional. It doesn't really have that much inheritance or structure to it. It's just more to get the job done. So let's say we wanted to return a function, add y to x, and we'll put y in there, and we'll just return y to x. Adder accepts x and returns the function. So let's say we said add 10, or yeah, add 10 tenors. I feel like there wouldn't be a plural for this, but I'll just put 10 then. Let's say we said add 10, and we had let's add 5. These two return a function with their x variable, this one equal to 10, and this one equal to 5. So if we were to log, and we call add 10, and we add 100 to 10, and we were to do the same with add 5, and we add 100 to 5, this one will return 110, and this one will return 105. So when we run it, we'll have 110, 105. So it's contrary to what we just did with my name. And when we redid my name, it changed it. But this one doesn't change because we're using it in a scope of the function like this. So basically what we're doing is we're storing the value of whatever x is, and we're placing it inside of here. So when we return it, x is saved as like a permanent. You can't change it after you call adder, unless you make a new adder, like you use adder again. So this has some uses. So we can make a function add 10, and it'll add 10 to whatever we put inside of it. And we can make a function add 5, and we can add 5 to whatever we want. So we can do the same thing with like strings or something, like we want to add an s or we want to add something, and it has that type of functionality. So let me go back to the slides. After functions, I'll review objects, or after functions, I'll review arrays. So let me go back to this. So arrays. Arrays in JavaScript are defined with any of the three var, let, const, and var. And we can set it, let's say we say an Armando's, and we set it equal to an array. These signify an array. And we could put any type of data types or objects that we want in here. So let's read like 3. We had hello world. We had true, undefined, null, and we'll just leave it at that for now. We'll just have the 1, 2, 3, 4, 5, 5 in the array. So if we log some index in the array in Armando's, like 1, and we can concatenate something at the end, like Armando. I don't know. I'm using a name. I decided to pick a name. It says hello world Armando. Since we're calling the first element, which is not really the first, we're just calling the first. I don't know how to say it. The element at index 1. This is element at index 0. All arrays start at 0, and then it goes 1, 2, 3, 4. Only slightly famous. So if we were to change hello world, we can access the index or the element at index 1. We could say now it's I don't know, Cameron, and we logged it here, and we said Armando's 1. We said is a new name. It'll say hello world Armando, and Cameron is a new name. So we would change the first element in the array Armando's to Cameron, but we could also change it to 24, and we could say 24 is better than 23. Do you use the dollar to reference the array in the same way? So we could, yeah, we could also do backticks here. Let me, and we would do it like this. So then 24 is better than 23. 24 is better than 23. When we use this, this notation, we can access any variable. 25 is better than 24. Yeah, I'll just change it. I'm not sure what the difference is. Oh, I guess it's a pretty good coincidence. So we reassigned it to a new data type. At first it was a string, and then it turned into a number. A number is not a string, but it still accepts it because JavaScript is, I said it earlier, that JavaScript, it's wow, it's skipping my mind right now that it's different than, it's not static, I think it was. My director's off, I can't ask him for help. Yeah, that it's dynamically typed, yeah. I was having the biggest brain fart. That it's untyped. Yeah, that variables are untyped, that you just combine it with yet. Yeah, that it's untyped. That you're able to redefine hello world. The first index in the array is 25 because JavaScript is untyped. So as I was saying with arrays, first I want to make sure, is everybody okay? Did I lose anybody? Those Python fields. Good here, just eating. All right, okay. All right. Doing great, okay. So we redefined it. We could also define a new index in the array. So I won't do it here, I'll do it after. And we'll define 5, and we'll say it's equal to good. And instead of logging this here, we'll log armando's.length, which gives the size of it, which currently it's 1, 2, 3, 4, 5. And if we log it here, after defining a new one, after we add the 5th element, since there's only, once we access the 5th index, which will give us the 6th element in the array, the size will increase to 6 rather than 5. So the first one prints 5 and the second one prints 6. So we can add new stuff, unlike Java, which most of you might be familiar with. We can't just access something that's out of bounds in the array than it was originally defined in Java. But in JavaScript, it doesn't really matter. We can just define a new one, like 5, and it'll be all good. And it will update the length, and it will just allow good to coexist with all the other 5 elements. I wish it was 4. I could have made a avatar joke, but let's say we set, instead of indirectly setting the length like this, we set armando's.length, adding to index 10. So we added to index 10. It might do as you anticipate. Let me remove that Armando's. And it'll expand it to all the way to 11. It'll be one more because you can only, since it starts at 0, the size will always be one more than the last element in the array. So it'll expand it all the way to whatever you do. So if I did 100 or something, it would do it to 101. And all the variables in between, let's say we logged one, for example. So we logged some variable in between. So Armando is 50. And we refreshed our browser. It's undefined, as is like 6 through 99 that was newly added. All those will be undefined because we never defined them. So aside from adding the length like that, let's say we wanted the last one to be undefined as well, and we wanted to do it in a elegantly way. we could also just set the length variable, Armando's.length equal to 100, or let's just either equal to 10, and let's print it again. It'll be 5 and then 10. So we just set the length to 10. And if we were to access the 10th element at the 9 index, it's also undefined. So this is another way, other than just setting Armando's 10 to nothing or something, we can just set the length to 10 and it'll expand the array for us. So we could also just run through this array. So we'll run through this conglomerate of random variables. We could use a for loop. We'll start at the 0 index. We'll go all the way to Armando's.length, and every iteration will add 1 I, and we'll just log Armando's at I. Oh, I put int. That was bad. I meant to put length. Let over length what we'll print. So if we were to try to print 10 right here, oh, we have too much print statements. Let me just remove a couple. Yeah, my Java was showing, and I haven't coded in Java in a while too. It'll also just be undefined. So if we tried printing at 100, just so you know there's no funny business, it'll just be undefined. Let me redo back up to here. Let's still set it to 10. No problem. And we printed all the things in the array. The first one's 3. The second one's 25 because we redefine it. Third one's true, undefined, null, undefined, null. And then we'll have 5 undefined because we increase the length. Is there any reason you do plus plus I and not I plus plus? Or is it just, it's second habit. Like if someone does I plus plus, like they just do it without thinking about it. I do plus plus I without thinking about it. It's just something both will have the same result, yes. So just to show you real quick, we had I equals to 0 and we had I plus plus. I plus plus returns I. Tabs or spaces? Tabs. I plus plus returns I and then adds 1. So I'll remove this console.log. So it returned I, which I is 0, and then it adds 1. Yeah, I plus plus does create a temporary variable that returns, but then most compilers, if they notice that you're not using it, it'll just put plus plus I. And usually the change is so minuscule that I wouldn't worry about it. I plus plus I adds to I and then returns I. So it'll be 0 plus 1, and then 0 plus 1 is 1, so it'll return 1. So the difference between the two is if you need the variable afterwards. Since we're in a for loop in the increment, we don't need the variable. So it's kind of pointless to debate which one or what. So we could put either one and it'll work just as fine. No problem. So let's say we wanted to print all the things in Armando's. We could do just like that. And it'll go through 0, 1, 2, 3, 4, and it'll just print the Armando's. I think I just finished with that. So does anybody have any questions? Have I lost anybody? Is everybody good? All right. So let's say we moved on to the second part and we try to concatenate arrays. That'll be the next thing. So we have 1, 2, 3, and my concat array. And we'll just re-instantiate it to itself and we'll concat it A, B, C. And we logged our concatenated array. We'll have each one, 1, 2, 3, and then added A, B, C. See, if we did it the other way, we would release all of our passwords, so we had to do it this way. There's also join, which will, instead of concatenating A, B, C at the end of 1, 2, 3, it'll return a new string, joined. And unlike this one, it's just going to join them by something. So let's say we wanted to return it as a 1, 2, 3. It returns 1, 2, 3. So my concatenated array is now a joined array by definition, but it doesn't matter what we name it. So this just adds, like, instead of putting these, like instead of having these separate elements, it'll join each element by a comma, not including the last one. A lot of languages don't have this feature, like as easily accessible as JavaScript does, and it's a pretty unique feature. It's pretty like good. It's just express. You want to make it into a string, and you can use that one thing. We also have push, which, let's say we have a new array equals 1, 2, 3, and we want to push to the array. Let's say 10 and 11, and we print it. We'll have 1, 2, 3, 10, 11. So it's kind of like concatenating arrays, but with concatenating arrays, it returned the concatenation and didn't actually set new array. Push sets new array to have 10 and 11. Concatenating doesn't set it and just returns it. So it's useful if you want to keep the original state, because new array, the original state's now removed. You cannot access it after this. So join just manipulates what happens between elements. Yes, it puts the elements. It puts the elements with whichever string you have between them. So if you want to express it as one thing, so let's say we had like a list of names. So if we had me and myself and I, and we join them together, Zach, myself, and I. So it just returns a new string that has these separating the elements. So the usefulness is if like we had all the colors in the rainbow, then we could join them by this and then say all the colors in the rainbow. We could change it to all the colors. We could do like red, blue. If we did no comma, well, I did a comma and space, but if we didn't, offline. If we did no comma or space, they would just be squished together, yeah. So it would just make every single element joined on top of each other. In other languages, you would usually just do a for loop and then concatenate onto a string. But in this one, it's just, they have the method already embedded into the array. Make sense? Wow. Okay. Yeah, I thought it was too. I like JavaScript for some things. It's really useful for web development. It's like one of like the best tools. So I just showed push, which pushes it, doesn't return it, unlike concatenating. So let's do a new array. Let's reinstantiate that one, and we'll just have it as 1, 2, 3, and we'll push to it again, and we'll push 5 and 6 this time. So we're just skipping 4, and we wanted to get the last one. So I meant to make a new line. The last element is equal to new array dot pop. What this does though is it takes the last element and literally takes it, it removes it from the array. So if we were to print last element and we were to print the new array, let me save the file. So 6 is taken from the array, and now we have 1, 2, 3, 4, 5. But 6 is taken. You can think of like a soda cap. You pop it off, the soda cap's no longer there. That's what I think of every time I read pop, or British people. But Pop is pretty useful if you want to start removing from the array and you want the last element each time. We also have unshift, which, let me do, I don't know why I delete new array every time if I'm going to reuse it. Just keep it there. So unshift, if we did new array dot unshift -1 0, and we printed that new array. Oops. So it's moved all the stuff. It's shifted the array. It's not shifted. I wouldn't think of it as that. It's shifted the array forward, and then it's added new variables. So if we put 10 here, it would have -1, 10, 1, 2, 3, 4, 5, 6. So it's not like it added 0 and 1 because it was the next ones. It just added -1 and 0 because we told it to add those. So it shifts all the arrays and adds whatever new ones we put inside the method. And just like push, this one changes the array, so it manipulates it rather than like returning a new array. And other than unshift, we have shift, which doesn't take any. Shift is the opposite of pop, so it'll take the first one and it'll remove it. So instead of having 1, 2, 3, 5, 6, now we have 2, 4, 2, 3, 5, 6. So it's like the opposite of pop. It would have been cool if they did some like they're opposites and they mean something, like shift pop doesn't really mean anything. Like, I don't know, pop lock, I don't know. Always the possibilities when I make a programming language. Anyways, do I have everybody's good? Do I continue? Do I have any questions? No question. Okay, perfect. So let's say we define colors like we did earlier with the rainbow. We had red, green, blue. Instead of doing a for loop that runs through each one like this would, and then we go through the length of it. Instead of doing that, JavaScript has for each as a function in each array. And inside of for each, we have to provide it's called a callback, but an arrow function will do. So let's say we did an arrow function. Oops, I meant to do curly brackets. You're kind of confused with the dot length. Okay, I'll go over the equivalent right here, right after for each. So for each has an arrow function with the element. So it does each iteration of this arrow function with that element. So if we were to log it, element, it will log separate red, green, blue. Let's say we would do it with the dot length. So we had I equals 0, I is less than. We want it colors dot length. Colors dot length will return 3, 1, 2, 3. And the first index starts at 0. So if it'll run 3 times, if it runs 3 times, the first iteration, I will equal 0. The second iteration, I will equal 1. The third iteration, and the final one, because it'll only run 3 times, I equals 2. So we'll access the second element, the second index, which is the third element. So the length will be 3, but we only want to access up to 2 because the array starts at 0. Does that make sense? Or more sense? So if we were to log the colors this way, and we said colors, and we accessed I, it'll do red, green, blue, and then red, green, blue again. Does the dot length make a little more sense? Okay, that's good. So let me remove these. And let's say we wanted to filter colors to have like a certain, like we wanted some type of requirement for each one. So let's say our requirement for each color. Oops, like this. Okay, I'm like a type as smooth as you low, I can't spell. Yeah. I'm on my laptop, so it's quite hard to spell on this one. So I've been having some errors, but I hope it's going smoothly. So let's say our filter, we want it to return some value, or we want it to, let me reformat this just a little bit. So it's like this. We have our arrow function, and our arrow function, we want it to return some value. So arrow functions have this unique functionality that we could either say it's not red, which will say if it's red. If it's not red, then we want it to return true. And if it is red, then it will return false. So if we filter and then, oops, and then we said no red, and we print it, no red, then it'll have green and blue as the array, as the two indexes in the array. But if we wanted to use the bracket notation, we would need to put the return statement into here, and then it'll return green and blue. So what that is it's a functionality of the arrow statement that if it's a one-liner like this, delete that. If it's a one-liner like this, it'll have the return statement. It'll imply the return statement for this operation. So then we'll have green, blue. So if we wanted to exclude all greens, then it'll be red, blue. So besides filter, we also have map. So delete this. Let's make a menu, which is going to be an array of like a navigation menu. So I'll name it slightly better, just so it's, or a navigation. So let's name it that, menu. And we'll have home, about, services, and policies. I think that's usually on a website. If we wanted to map each of the things to a specific string, like we wanted to display it with that array, like we wanted to convert this into a list, like each one as a list item, we could say navigation menu. I'll rename this to nav bar, just so we have some difference, so it's not as homogeneous. And navigation menu, we can map each item in it. And I'll use the backtick so we can embed it into the string. And we'll put it inside a list item, which is HTML. List item is li. And we'll put item. It's a little off. I'll scratch over here. Make the console bigger. So nav bar now, if we log nav bar, oops, and we print it, we have each element in the array changed by whatever we mapped it to. So we have home, about, services, policies. So now we have li on each side. So let's say we wanted to just make them the plural version. We could just put like an S, and we'll remove the S's here. And we'll change this to landing page, and we'll change this to like blog. That way it makes a little more sense. But now we have landing pages, blogs, services, policies. That way we can change the element in the array to some degree. So if we just wanted to change them like all to 1 or 2, then we just change them all to 2. But the functionality of this is that we have access to the old value of that particular index. So if we wanted to change it all to the item.length, so how long landing page is, it's like 20 letters, and this one's like 4. I guess it was like 12 letters, but it mapped each one with the length of what it originally had. So one had 12, one had 4, one had 7, one had 7. So map's pretty useful for like converting arrays of one thing or adding to the array. So now moving on to the next one, we can define some type of, we can use something called reduce to run a function on each element of the array. Ooh. Okay, sorry. Each element of the array. So let's read the ages 19, 20, 21, 22, 23, 24, 18, 10, 50, 60. And we set a sum of ages under 22 seems to be in the middle. And we call ages.reduce A and B. So we said FB is less than 23, or I defined it as 22. Then we want it to return A plus B. So it's saying ages of less than 22. A is the existing value that's going to be repeated throughout the whole loop, and B is the value of the array. So let's say we had 19 and A starts at 0. That means it'll be 19 in the first iteration. And in the second iteration, it'll be 19 is A and 20 is B. 20 is under 22, so then it'll be 19 plus 20. But if it's not, then we're just going to return A plus 0. So let's log each iteration just to see how the sum changes over time. And if we wanted to use more descriptive names, we could change this A to sum. Oops, let me change that A to sum. And we could change the B to element. And if we logged each sum, and it said comparing new element, and we concatenated element as well, so we know which element we're on. So the first run is going to be 19. The sum is 19 because the first element is 19, and then it's comparing 20, so it'll add 20. 20 plus 19, 39. So sum is kept throughout the whole loop. It changes as each one goes on. And then element is the next element in the array as it runs. So there's other elements like sort, slice, splice, find, and a bunch of others in the array that are really useful that most languages don't have. But for now, I'll move on to the next subject, which, let me go back to the PowerPoint, is objects. Objects are it's very similar to other objects in other languages, but there are some distinct differences between them. So we could define an object like my car, and we could give it properties. Let's say the make or model, like model better, is Tesla. And the age of it is, I don't know, 30 years, or I don't know, 1 year. And I give my name, my car name, so its name is John. Now we can access those variables that we defined, or properties, as such. So we could say my car dot age, and it'll print the age of the car, which I've defined as 1 earlier. And we can do the same for model and name. We could also access the properties in a different way. We could access it like if it's an array, and we could say it like this, and it'll print Tesla. If we put name, it'll print John. This is really useful because in a loop, you can't exactly use the dot age. You can't do this in a loop if you wanted to access a bunch of properties it had. But in a loop, you can access it just like this. So if you had a bunch of properties that were like 1, 2, 3, you can access it in a loop. Or A, B, C, you can access in a loop, looping through the letters of the alphabet or the numbers. So it's convenient that it has this feature that you can use it like it's a key and then a value in this way rather than accessing it using the dot operator. We could also define a function that will return a object. This is also called a constructor, or it should be called a constructor. So we had model age name, and we'll just say this dot model equals model, which defines the property model as the parameter that's passed into car. And this dot age equals age. This dot name equals name, or name, yes. And whenever we call this method or constructor, it'll return the object that we want. So if we wanted my car or Zach's car, and we said new car, and the model is a drivable one. I'm not into cars. I don't know. Other than Tesla, I can't think of one right now. I think what are they called? Audi. I think they're called Audi. I might be like butchering the name, but let's say the age is 10, and I named it I don't know, John 2. This will return a new object with those 3 parameters. So we can define a constructor that'll start making us objects. So we have some more strictly typed code other than just making a object like this. So we say Zach's car 2. Instead of making an object like this, where we might mistype something or it doesn't make it for us. That's the kind of one, a drivable one. Yeah. Instead of like defining it ourselves, we can just use a constructor and it'll define all those properties for us. Let's say we wanted to make another one that was, I don't know, Cameron's car. And we said new car. Someone said Toyota Corolla. BMW. A BMW. And the age was, I don't know, 5. And the name is Toyota Corolla. Now, if we printed both of these cars, Zach's car, we printed Cameron's car, it'll print the 2 objects. One's an Audi named John 2, age 10. They're separate between each other. They're not linked, which is important because we want unique objects for each constructor call. It's very similar to like Java or basically any language with a constructor. It looks a little weird saying function car because usually we'll have function of the name of the class, or it looks like a standard function call. So it might be a little confusing in that regard. We can also have functions as property values. So let's say we wanted to also define this dot drive, and we wanted to call it as a function. So I'll move to the other notation first. So when we had John's car, my names are too original, I know, and we had a model, and we'll say it's BMW. We had an age, and we'll say it's fresh out of the gate, 0. And we have a name, and we'll say Bianca. And we want to define one of the properties as a function. I guess you could see it that way, I guess. And we want to define one of them as a function. So we have a drivable function. And let's say we wanted to like say just print out we are driving. Oops, I forgot a comma here. We are driving. So now, whenever I reference John's car and I call drivable, it'll say we are driving, which is, it's the same thing as methods in classes and other languages. So we can also add some functionality to this. So let's say we define a book, and it's a Game of Thrones book, which was made by George, and it has 50 reviews. And we wanted to define a function that was add to reviews. We could do it this way, which will add it to as a function, or we could define it as such, where we just call, it's almost like calling it, but we just define it with no colon and no function keyword and number of new reviews. So it adds it to the review variable. So we're going to access the other variable, and we'll say this dot reviews plus equals number of new reviews. And every single time this changes, we'll log this dot reviews, and we'll log this as an object just to see how it looks. So let's say we made a new book. So we already have the book because we defined it as such, not as a constructor. So when we call book dot add to review, and we added one review, it will print 51, and then book as a object. And you can see add to review as a function in there. Google Chrome will tell you a little about it, but it's not really relevant to what we're doing right now. We can also use an arrow function inside of the properties. So if, oh, I messed up. So this is already defining it using an arrow function. And we can tell because it uses this keyword. If we were to define a function as such, like this, like we did before, if we were to define the function like this, and then we ran it, well, I must be having a brain fart or something. Number of reviews, this dot reviews. Both of them can use this. Okay. So when we define it as this, we're using the function keyword and we're defining it as a function. And when we define it like this, we're defining it as an arrow function. I previously thought that this would not work because this is defined as a function, so it's not binded, but it is binded. And what I mean by binded is when we use this, we're calling the object at hand. And when we have a function, usually you need to bind this keyword to the function. JavaScript doesn't exactly know that this function has access to this keyword. So usually we would need to bind this to the function. Arrow functions eliminate this, and when you're defining property as such, since it's already in the properties of an object, you can already use this keyword. So whether you refine it as a function or as an arrow function, you can use this keyword because both of them are binded to it because they're properties. Do you have any questions? I'm sorry for my brain fart like 5 seconds ago. But if I have any questions to answer, that's awesome. Did I lose anybody? So let's say let's move on to looking at string variables. Let's say we had a name, like my name, and we printed the length of it. Type in the name. And we print the length of it. My name is 7 characters long last time I checked, and it prints 7 characters long, so it prints how long the string is. But let's say we wanted to like correct the model number of BMW. It's usually all uppercase, so we call the to uppercase method, and it'll make it all uppercase. Or let's say we typed my name and we wanted it to lowercase, then oops, I didn't save the file. Then it'll change my name to all lowercase if we spelled it right. It'll change my name to all lowercase. So this is useful. So if we wanted to like just change this to lowercase, I'll show, we could take part of the string using some method that I'll teach you later on. And then we could change that part to lowercase and keep the front part to uppercase. Let's say we wanted to check a password. So we have a password that's ABC123. And then at the end it says password in all caps. We could test if the password includes ABC123. And since the password has one ABC123 in it, it'll return true. The recorded video for on your site, I know it's uploaded to YouTube a little after, like as soon as it's done processing and we have the video ready, and then it uploads to YouTube, but I'm not sure when it gets uploaded onto the site. Do I have any questions relating to this, how includes work and stuff? Okay, then I'll move on. We also have the repeat method. So let's say we wanted to repeat the letter A, and we wanted to repeat it 100 times. We could log repeat now, and A is going to be repeated 100 times, whatever string that we repeat. So I'll have 100 A's. And if we put 4 A's, then we'll have 400 A's. It's a really simple method. It's pretty useful for formatting. So a lot of people will want stars between their messages or something, and they'll add like label. So then it adds a star, 5 stars as the prefix, and then the label. So it's pretty useful for that. There's also some number methods. So let's say we had a total of 69.420 or 0.42, and we logged 2 fix of total. This will round it off. Ooh. Let's add a bunch of 2 so we can see it. This will round it off to 2 decimal places. Just give me 1 second. My dog is starting to bark at me. I just need to give him some food. Just give me 1 quick second.
Hey everyone, I hope you're enjoying the workshop so far. Oh, Zach's back.
All right, I'm sorry about that. So this rounds it. In Java, it's usually much more complicated to do. So I like how JavaScript really simplifies it to just 2 fixed on a number. Usually people like interpret we're using a method on a primitive, but JavaScript wraps the value in a wrapper class and then does whatever method and then destroys the wrapper class. So this total turns into the wrapper class of a number, and then it calls toFix, and then that wrapper class is destroyed. So it's like we're calling a method on a primitive, but we actually aren't. It's actually making a wrapper class, calling a method, and then destroying that wrapper class and replacing it back with the primitive. Does anybody have any questions about that or no? Are we all good? Okay. So there's also the REST operator, which is quite a bit of languages. So when we use the REST operator like this, it defines some amount of args. So here I have an arrow function that has the parameters of args. Args is like some amount of args that we don't know beforehand. This is, for example, a class list. So we'll define a students and we'll map to the args using the students. And we'll say if it's the last student, then we'll just add the student to the students. Like so. But if it's not, then we'll say add the student plus a comma. So let's say we return the students and we want to call this, we call class list. And we put in a bunch of student names. We have Zachary and I was going to copy people from chat, but I guess I'll manually type them. Johnson, and we have Cameron. This, when we refresh the page, class list is not defined, so I accidentally did a capital there. When we call it, we have to call the same name. Class list is still not defined because I never saved the file. 2 common errors. So Zachary and all the students are concatenated into, is this similar to array list? The REST operator is kind of similar. It's that we have all these parameters, Zachary, Michael, and Cameron. We have all these arguments, but we don't have to define them here. So we could have defined an array list here, like in Java, in Java world. We could have defined an array list, and we could have made an array list, added these 3, and then passed it into here. But instead, we're using the REST operator, which allows us to define an unsized array almost. And then we're using that array and we're mapping to it. Yes. We're using that array and we're mapping to it. And we're just gonna have a student variable. And we're adding the student to the students variable. So args is the array that we're mapping, and we'll have an undetermined amount of parameters that's going to be passed into class list. So it's kind of like array list, as in it holds some amount of stuff, but its functionality is different. So we can also define REST operators in a different way. We could say const, let's have the first name, and then other names. So we'll set this equal to Zachary, James, oh, that's games, James, Santana. And let's say we do console.log the first name and other names. It'll return Zachary, and then it turned it as an array, James Santana. That's because the first one is just a singular one variable, and this rest operator says the rest of the variables put it inside of other names. So the rest of these put it inside other names. I think that's really all I can explain with the rest operator in this. If I added a third one or a fourth one, we added there. Do I have any questions? What does it mean for something that's dynamic? Meaning it could change over time, there's no set or size. Yeah, dynamic means, in a loose sense, it means not constant. It's something that we can change. Like in JavaScript, all arrays are dynamic. But in Java, for example, arrays are not dynamic in that you have to make a new one to increase the size. So they're very restricted. In JavaScript, you can just add a new one to the array at the end or past the end, and it'll just expand the array automatically. That's what we mean by dynamic. If we have a spread operator, x, y, z, and we returned it. This is not the spread operator yet, but this sum function accepts x, y, z. So let's say we have some numbers that we want to add, and it has 1, 2, 3, 4, 5, and we wanted to add the first 3 into sum. Instead of calling the references like numbers 0 and then numbers 2, number 1, and number 2, we can unpack numbers with the spread operator. And when we run this, it'll run 6, which is 1 plus 2 plus 3. So it disregarded 4 and 5 because the parameters of the method only include up to 3 numbers. So if we wanted to concatenate if we wanted to make a new array that had numbers and more, so a better array than numbers, then we would have the rest operator with numbers, which unpacks it. So this is replaced with everything inside of numbers, 1, 2, 3, 4, 5. And then we could add 6, 7, 8. And if we print new numbers will be an array of length 8, and it'll have the 3 new variables that I added, or yeah, 3 new variables that I added. The 6 from before is from the earlier console message. So if we wanted to, we could have an array of colors like we had before, of red, green, blue, and we can use the spread operator, or not the spread operator, but we can deconstruct these into their own variables that we can name whatever. So we can name red R, green G, and blue B, and we could just deconstruct them. And doing this, we could log R, and it'll give us red because it deconstructed it. So colors is plural, and it'll deconstruct it to red. So let's go back to the PowerPoint. So functions, we already covered functions, and we already covered arrays. If you guys want to go a little over this slide, we went over slope and closures, how the functional statements nest inside of them. We went over arrays, how they start at 0. The length gives whatever, how many there is. So in red, green, blue, there's 3. Arrays are dynamic, so they can change in size. Press the up arrow. And then we just went over objects, how we can access them using this notation, and we can access them using the dot notation. So now that we've gone over the 3, one second. Okay, I'm sorry about that. So besides objects, besides this notation that we can use to access the variables, we can access the actual objects and modify them in different ways than we can usually do. So let's say we defined an empty variable, an empty object, which is this curly brackets, and we call empty.toString. We notice how it says object, but we never defined a toString function as a parameter. So we never did what we would classically do as this, and then say hi. We never defined a toString variable. So where is toString coming from? So this is because every JavaScript object like this has a prototype. If we log empty.prototype, this will give us, oh, did I spell it wrong? Prototype. It should have printed out the prototype. That's really weird. Once I move on to the later examples, I'll show you what I mean by that. I'm sorry about that. Let's say we defined a constructor person, and we have a name variable, a age variable, and a favorite books. And we defined each instance variable too, with the accompanying parameters. And we defined a function as well. So this dot birthday, and I'll use an arrow function. We'll say this dot age plus equals 1. We'll say it is your birthday. And then we'll add their name, this dot name, space. You are now, and we'll add the age. If we run this, nothing will happen because we actually never called the constructor. So if we made a new Zachary or Tim, I'll use someone else for now, new Tim, and we said their name is Tim, they're 23 years old, and their favorite book is Ranger's Apprentice and the Hunger Games. Right now, it'll print nothing because we never made a function call. We just defined an object. That object has these parameters. So we never have a function call. So if we were to actually call Tim dot, let me change Tim to lowercase. Tim dot birthday. It'll add his age by 1, so it'll change him to 24 years old, and it'll print, it is your birthday. So if we try doing Tim.prototype, it should print. It's really weird. It should be printing the prototype. We'll have documentation on it on the GitHub and on like future resources that we'll provide, and we're always in the Discord chat. But it's really weird that it's saying undefined right now. I'll definitely look into that. Another way that we can define a class, other than by this, we'll define class person. This one will be lowercase, just so it's different from the last. And now we'll call it with what most people are more familiar with, which is a constructor. And this allows for more object-oriented code. You can see it way more than a function that returns an object. Now we're actually creating a class. And unlike Java, you don't need to define the instance variables at the top. Once you say this dot something equals something, just like an array adds new things, then this will expand its own repertoire to have a new name variable. With toString, I was trying to show something different. I was trying to show some of the behind the scenes for a object variable, but I could not. So for example, we never defined the toString. In the behind the scenes, it shows where it is defined for the object. But since we can't actually see it, like it's saying undefined, we can't actually see the behind the scenes. But that's what I was trying to do with the prototype. So let's say we have this new class variable person, and we wanted to define it the same way we did above with the birthday method. And we did this dot age plus equals 1. And we did console.log. I'll just copy and paste this because it's going to be the exact same method. And we ran it. We won't have any error because we never actually defined a new person object. We just defined the class. So if we defined a second Tim, and his name will be Roger. Oh, look, I named him Time. How embarrassing. And Roger is going to be a 15-year-old, and he doesn't like any of these. He likes The Giver, and he likes, what's a book 15-year-olds like? 50 Shades of Grey. Tim, or now this new Tim, or Roger, when we call his birthday method, using this class definition, it'll look exactly the same as our previous person method, or function. So it doesn't matter which way you choose for functionality. You could get the same thing accomplished with both. But one of the things that you cannot accomplish with the function that you can with the class is inheritance. So let's say we were to find a teacher and we want it to be a person. Although I think most are, but some aren't. We have the constructor, and we'll have the same thing as before for our person class. But now, since this is a new object, we'll probably want to add a new functionality, and for this one, it's going to be school. So the school that they work for. So since it's inheritance, we can just call name, age, favorite books. We'll have to call super in the first line. This is saying call the inherited constructor. And then this dot school equals school. So we can say that as another variable inside the objects. And now I define a new method too, which is print message. We'll just say my name is, and then we'll print this dot name, and teach at this dot school. Let's define a new one. Jim. My guy Jim is a teacher, and he goes by Jimmy in his name. He is 100 years old, and he likes War and Peace and cookbook. Those are his two favorite books, and we'll call Jim.printMessage because that's the one that we defined in teacher. And he says, my name is Jimmy, and I teach at undefined. That is because when we said new teacher, we actually only defined 3 parameters when we called it. So we called name, age, favorite books, when we should say FIU at the end, and he teaches at FIU now. So we could also supply the default school, saying it's FIU. If a lot of our teachers go to FIU in our system or something, and it'll say I teach at FIU, so we don't need to provide it when we say new teacher. So those default variables still work for constructors, and they'll still work for any method calls. Do you have any questions? Is anybody lost in this? So what I was trying to do before with the prototype, I can do object.get prototype of, and let's say we do it of Jim, and we refresh the page. This gives me the prototype or the superclass of Jim. So Jim is a bad example maybe for the first time, but he's a very good example when compared next to person, because they both have different superclasses. So give me 1 second. So person and Jim both have different prototypes. Person, let me get the defined version of him, Roger. If Farrell is defined by default, can you override it later on? Yes, so this person that works at FIU, they can work at MDC. I don't know, they got fired. So now they work at MDC and our print message says MDC now. So we override it. The default's default just in case like there's no thing required. No problem. So when we get the prototype of Roger and Jim, Roger is of type person and Jim is of type teacher. So for Roger the person, the prototype is just of an object and it comes with these defaults. So we can see the toString method that we called earlier. We also have value of, and we have a bunch of other ones that we don't really use that much, but it's inherited from object. For our person one, the inherited Jim is a teacher, so its prototype is a person, which is his inherited class. So it comes with the constructor, and it comes with the print message. Not the person, the Jim. But Jim's inheritance is from person, if that makes sense. Does anybody have any questions? Is like the behind the scenes, what it inherits from, and then what is it getting from itself? So everybody good on classes and objects and prototypes? Okay. So the next thing I'll do is document object manipulation. So we're going to end it by adding some JavaScript to our portfolio, which our portfolio is what we made in the first web development. It looked like this. I won't go through coding it, obviously, that's what we did in the first one, but we did make a form down here with a submit button. As it stands, if you fill this out and you click submit, it will actually not do anything that we want. It'll just redirect me to my C drive. Well, now it says my index.html is moved. I think it's this one that I'm looking for. Yeah, that one that I was just looking at was the portfolio. I moved the portfolio earlier. I'm sorry about that. But what the point was that we're supposed to add functionality to our form. And by doing so, I'm going to open up the web dev 1 workspace that we had before. Okay. And I'm going to go into the HTML and I'm going to add a new script. So we already have this script, which is something that we discussed in Web Development 1. So we're just going to add a new script and we're going to reference our new JavaScript. So to add it, I'm going to add a new folder and I'm going to say scripts. I'm going to add a new file and I'm going to say form.js. And inside our source, let me just finish the closing tag for that. Inside our source, I'm going to go into scripts. I'm going to go to form.js. And this imports the scripts form.js into our web browser. So if I were to open this in File Explorer, and I were to open the index.html, this is the contact form at the bottom. We look at the source code, and we go to the head. We can see our script tag right here with script/form.js. And now we can actually add the functionality to our form.js for the form. So first, we're gonna recall what we labeled our form. It was here. Our class name is contact form, so we're gonna use contact form in our JS. Let me go back to, oh no, I'm already on that page. Okay, perfect. So first, we're gonna grab the form using the, perfect. First, we're gonna grab the form using a query selector. Our form name that I copied and pasted was contact form, which is our class name to be specific. Since it's a class name, we want to access it the same way we did CSS classes, which is a period in front of it. If it was an ID, we would put an hashtag in front of it. So the period in front of it signifies a class name. This method grabs the first element in the HTML document with that class. So if we had multiples of contact form, it would grab the first one. Since we only have one, we don't need to worry about it. That's going to grab our only one and only form at the bottom. We can also grab all the inputs inside of this form. So our inputs is in this div right here. We have contact input, and this one has an ID of name. This one has an ID of email, and this one has an ID of phone. So we want to grab the elements by their ID. So the name input, we'll grab it by doing document, which is how we do the DOM, the document object manipulation. We can call document, which is going to be, we referenced vars before. It's a var variable that we can reference anywhere in the global scope. So this is one of the use cases for it still. And we can say get element by ID, and we'll just put the element ID that we want. So the first one was name, and we're grabbing the name. And the second one will be exactly the same method, except now we'll be grabbing the email. And then here we will put email. And the last one is the phone number. So we will grab the phone. We'll put phone. And the last one is the message text area. Message text area input. So these are all the form values right now. Since this is ran as soon as the website starts, if we were to do console.log any of these, and we were to refresh, we can see that it says null, because these are just the inputs. These, we haven't actually done anything with them, or we haven't actually accessed them. So if we were to do form.add event listener, and we want the form submit event, and we'll add an arrow function with the event argument passed through. We can say event.prevent defaults, which is earlier when I clicked it, it just redirected me to my C drive. So if I click it now, if I had filled information, it would redirect me to my C drive. I don't want that, so I'm going to prevent that from happening. And then I'm going to get the name, which is the name input.value. Oops, that's node value. I want just regular value. And then I'm going to get the email, which is the email input.value. And then I'm going to get the phone number, which is the phone input.value. And then I'm going to get the message, and that's the message text area input.value. So now I've retrieved all the information they put in the form, and now I'm going to concatenate it into a easy to read form values object. So this object will have email, name, phone number, and message. These are all shorthands for defining the attribute's name, the property name, and the value of it. Since we already have them defined as name, email, phone number, message, we can just put the letter, the word, the variable name, and it'll define it as the name, and it'll have a value of name input dot value, but it'll also define the property identification. This reminds me of the Java code that is done in Android Studio. And since we saved it into that new object, we'll just print it in the forms. When we reload, it says can't read property of add event listener of null. So that means when we did query selector, our contact form, it's returning null. This might be that we did our script tag at the top. So if we scroll down and put it in the footer, after all this HTML is defined, and we reloaded it, it doesn't give us that error anymore because when we defined it in the header, none of our HTML was defined. Thus, it couldn't grab this. So when we put it in the footer, it can grab this because this is already defined. And it can define the add event listener, and it can add an event listener to form. The event is submit, so when we click the submit button, but the thing is that event's not passed until we fill out the form. So let's fill out the form. This is a message, and we click submit. We're given an object, and it has the properties email, Zachary at FIU, message, this is the message, name, Zachary, and phone number 11111. Does anybody have any questions on how I did that? Or any questions about how this works? And every time we click submit, it will run it because that's the event listener with submit. Nobody has any questions? All right, and I'm done with the JavaScript workshop. Here's some resources. I'll pass it on to yours truly.
Yep. So, all right, guys, thank you for coming to the JavaScript workshop. I do hope you guys learned a lot. Like I said, we're going to have who liked the workshop? We're going to have a Node workshop led by Lazaro, who's in the chat right now. That's coming up on October 16th, where we're going to dive into building APIs with Node. So yeah, thank you guys for coming. There's some resources. I also posted some more resources in Discord. This was kind of just like getting your toes wet with JavaScript, but you guys should just definitely go more in depth and learn more. It's a great language. I'd say JavaScript is probably one of my favorite languages. I use a whole lot. So, but thank you guys for coming. All right, I'll stop the recording. Recording will go up on YouTube in a couple of